Welcome to this video on displaying and describing quantitative variable. So by the end of this video, you should be able to make and interpret dot plot, stem plot, and histogram of quantitative data. You should be able to identify the shape of a distribution from a graph, and you should be able to describe the overall pattern such as shape, center, and variability of a distribution and identify any major departures from the pattern. All right, this is the data that we're going to be working with. You can take this data and you can follow the QR code that's on our first page that we did, not the Smelling Parkinson's, but the How Are My Favorite Classes Related, to go to the Statlet. And you want to use the one quantitative variable single group to input this data to create a stem plot, a histogram, and a dot plot that you're going to draw on question answer for your answer for number 3. And then we're going to go through that. So do all of those things and then come back to the video. All right, so hopefully you've done all of your drawings so you're able to take the notes for this section. The first thing was we took the data. The number of pairs of shoes is quantitative. It's a number that is meaningful if we measure it. So you should have entered the data at Statlet and made a dot plot, stem plot, and histogram. So we have our dot plot, our stem plot, and then our histogram. All right, let's start over here at our dot plot, and let's kind of evaluate what we're taking a look at. So dot plot's my favorite kind of plot to make. They're very simple to make. One of the things that I like, one of the reasons I like them so much is you can see the individual data. So you can see individual data. So I can look at this and I can see there's 250 people out here at 50. There's only one at 30, 3 at 20. I know the individuals of the data, and that's kind of nice sometimes. Another thing that's real nice is you can see the shape of the data. So the shape of the data is very important with statistics. It tells you a lot about what you're looking at. So you want to envision a loose, like a blanket being thrown over this data, real loose. So if I just had the blanket fall over the data like this, it's going to kind of look like that. So I don't want to follow it really close. I want this nice loose curve over it. And so that helps me understand something about the data. This is a shape called a right skew because the tail is pulled way to the right. Okay, and we'll talk more about the shapes in just a second. The problem with a dot plot is it's not good for large data sets. So not good for large data sets. So you can imagine you wouldn't want to make 1,000 dots and have them, like, you can lose count easy. It's easy to get them messy, so this is better with smaller sets of data. Now, anytime you draw anything, you should make sure we're putting some titles on it. So what do these numbers even mean? These are the number of shoes owned. Something along the line, what is the reader looking at? They have to understand what it is that they're looking at. So you want to make sure you're titling your graphs. In addition to titling, make sure you're labeling everything so it's easy for somebody else to read, that they're not trying to figure out what you're trying to convey, that it's very straightforward. We're going from 5 to 50. We've got dots. We can count them. Okay, so that's our dot plot. Our stem plot, all these same reasons hold true for our stem plot. You can see the individual data. Now this is kind of weird. What's happened here is the data has been split. A lot of times you'll hear this called a stem and leaf plot. And over here on this side, these individual numbers are the stem and the leaf is on the other side. So what's important if you have a stem and leaf plot is you have to have a key with it to show how to read it. So this is 5/0 equals 50 pairs of shoes. So 5/0, there's 50 pairs of shoes. There's actually 2 people with 50 pairs of shoes. There's 1 person with 30 pairs, and then we have 20 pairs, 20 pairs, and 22 pairs. So you've just split the number. Really important to know is you must include the key to get full credit. You must tell the reader how to read your stem and leaf plot to get credit for it. It must include key. It shows up on the rubrics all the time. Okay. Here, I didn't just say that it was 50. I said it's 50 pairs of shoes. That's context. It's important to remind your reader what it is that you're representing in your plot. Now, so the individual data, you can see the individuals. There's somebody with 2 pairs of shoes, 3 pairs of shoes, because it's really 0, 2, 0, 3, 0, 3. Okay, then we get into the double-digit numbers. You can also see the shape of the data. So this is how it's going to work. We're going to turn our papers sideways, and here we have our number line, the smaller numbers to the left and the bigger numbers to the right. If I throw a blanket over this data and let it kind of fall on it, do you see that same right skew? The tail is on the right, so it's still the same shape as when we did our dot plot. It looks a little bit different, but it was represented differently also. So that's why I like the dot plots and the stem plots, but I muchly prefer the dot plots. They're super simple. Now our histogram. So our histogram, you want to have your bars touching, because where one value stops, so we have number of shoes owned, the next value picks up. So we're going to go from one to the next. What's nice about it is you can see the shape. Okay, so think of that loose blanket. There it is, right skew, the tail's on the right. A histogram is really good for large data sets. The one problem that I don't like with the histograms is you cannot see the individuals. You cannot see the individuals. So here's what I mean. These are numbers of shoes owned, so 0 to 10 pairs of shoes. There are 13 people in there. I don't know what the numbers are unless I happen to have had the data like we saw over here. We did have the data, but if I just showed you this histogram, all you would know is that 13 people are in, we call this a bin. There's 12 people in this bin. Okay, so we don't know the actual individual numbers. Another thing that can happen with the shape is the shape can be manipulated. So that could be a negative. We could change the bin width. Instead of 0 to 10, we could have said 0 to 30, and that would change how it looks. So you wouldn't be misrepresenting the data. You wouldn't be lying about what the data was, but you're misrepresenting because of your bin widths. You can change how it looks overall. All right, so let's take a look. There's 4 things I always want you to talk about when describing a distribution. So we're going to describe the distributions. Okay, you always want to talk about shape. You want to talk about outliers. Let's put and gaps here. Center. Okay, and we're going to talk more about that in just a second. And variability, meaning variability is this direction, side to side. How spread out is your data? So what I like to do a lot of times is I'll write the first letters S, O, C, V on my paper, and then I'll talk about each of those things to be sure that I have addressed them. Okay, so let's talk about this shape specifically. We said up here that it was a right skew. So we're going to say skewed right, right skew, same thing. Just depends on how you want to say it. Okay, there's 3 main shapes that we're going to deal with in AP Stats. We're going to have our symmetrical. It's more of your bell-shaped curve. We can have a skew left. And your tail is on the left, the majority is on the right, or you can have a skew right. The majority of the people are in the lower numbers with only a few out at the higher numbers. That's what matches our situations. There's smaller numbers of shoes owned, but a few people had a lot of shoes. Okay, so those are our three main shapes. In this situation, outliers and gaps, we think there's potential outliers at 50. Be specific where you think the outliers are. Potential outliers at 50. You didn't say they were outliers, so you could be wrong. They might not be outliers. And there's going to be a rule that we'll learn, but not yet. You will. So unless you've proven that they're outliers, we're just going to say they're potential outliers and where they're located. Here, since we could mention here about the gaps, see how there's no data that falls between 40 and 50? So I'm going to say gaps at 40 to 50. So you're just describing what you're seeing to somebody else. Okay, then we have our center. We have a couple measures of center that we like to use. We could use our mean or our median. Both of them are in the center if it's symmetrical. So we'd have our mean and median kind of there in the center. But I want you to use the mean if it's symmetrical. In this case, our mean is 13.16. Use if symmetrical. Okay. The median in this case is 10. Use this if it's skewed. So we would use the median because where our data is skewed, our distribution is skewed to the right. So the median is a better measure of center. So the center of the data is closer to this 10 than it is to out here to the 13. That's why. So what happens is if I skew left, we have a mode, which is your most. Your mode is at your top. The biggest spot, that's your mode. Then your mean is going to get pulled way out here somewhere, and the median will be somewhere in the middle. Okay? If I look at my skew right, the tallest part, that's my mode. The mean gets pulled furthest to the right in this case, and the median gets pulled right, just not as much. Okay. Last one that we're going to talk about is variability. We're really talking about spreads. In this case, we can talk about range. We don't know a whole lot of other things right this minute. And so range is just your max minus your min, which in this case is 50 minus 2 or 48 pairs of shoes. All right, other things that could be range is we could talk about the IQR, which is the third quartile minus the first quartile. It could be standard deviation. We'll talk about standard deviation a lot. Or your range, okay? So which of these three types of displays do you prefer and why? That's completely up to you. I told you what I felt. My personal preference is the dot plot. In addition to, you can see the data and that you can see the shape and all of that. It's also very easy to make. Okay. Couple things before we turn this over. Sometimes I ask you to compare distributions. So if you're making a comparison between distributions, you want to use some words greater than, less than, more than. Some indication of how one distribution compares to the other in, maybe say we're talking about our center, and we could say the mean of one is greater than the mean of the other. You want some indication of how one is comparing to the other. The other thing I want you to think about is like a soft language. Okay, and what I mean by that is like these ly words where you say slightly. You could say approximately, these kind of words where you're kind of hedging what you're saying without being real definitive. Okay, if you say it is something and it's not, you could have a problem, but if you say it looks slightly that way, they could go, yeah, we agree. Okay, so you want to be a little softer on your language there. All right, let's go ahead and flip this over. Okay, here's data for a bunch of teachers that I collected for how many pairs of shoes do they own. I want you to take this information and go put it into the Staplet, just the teacher information, and take a look at the dot plot, the side-by-side. It will create a side-by-side sum plot. If you do one quantitative variable, 2 groups, you can do the students and the teachers together, and the histogram, and copy one of the graphs below for number 8. I did the histogram. I thought it was the fastest to draw personally. You pick what you want. Once you're done, come on back to the video and restart the video. All right, so here's my 2 histograms. Remember what I was saying about histograms is I like them because you can see shape with them. So notice we have the same bin width, so we can make a good comparison here. If I drop a blanket over that one and that one, we ran out of room to the left. We don't have symmetrical here, so this is skewed right, as well as the students one. Okay. Make sure you've labeled your axes. I've got the number of shoes owned. I've got my y-axis labeled. You could write frequency here. So FREQ, frequency, that's just you've counted. Okay. Now, number 9 wants us to compare the distributions of the numbers of pairs of shoes for students versus teachers. Be sure to address shape, outliers, center, and variability. So, what I want you to do is I want you to write your letters down the side. These are the 4 things you have to address. Pause the video, write a sentence or 2 about each one, comparing one to the other, and then come back and let's see how close you did, and let's talk about some of that. So pause the video and do that and come back. All right, so the first S stands for shape. So I say both distributions of the number of shoes owned are slightly skewed right. And okay, so we got shape. I went ahead and included the gaps here. I think I was just on a run. It doesn't matter where I included the gaps as long as I did. So I said that they were slightly skewed right. So I got a couple things here. I said shoes owned, and that's important because that's your context. So you want to be sure to include context. Okay. I used an ly word here. Really, the teacher's one is very slightly, and that one's slightly. So I just kind of hedged my bet and said they're both slightly skewed right. Then I said there are some gaps in the data. Okay, there are gaps in the data, but you want to make a point here that there's gaps in the data from 40 to 50 for students, and students is part of our context, while the teachers, there's some more context, had no gaps. That would be important. See, when we look at this graph, there's no gaps in data, but there is one right here for our students. So you want to make note of that. Okay, the second thing I wanted to talk about was outliers. We don't know the rule yet, but we can look at it and say there are 2 potential outliers at 50 pairs of shoes. So there's that context, 50 pairs of shoes for the students. And I was very specific about who I was talking about. And then I said, while, there's a comparison word really, while there appeared to be no outliers for the teacher's distribution. I don't know that there is or not, but I used the word appear to kind of soften my language just a little bit. Okay. Next we had center. I used median because our distributions were skewed. So the median number of shoes, context, owned by teachers is 12.5, which is greater than the median number of shoes owned by students, 10. So I kind of wrote two different ways to write this sentence. One, you incorporate the number as part of the sentence, and the other, you can just write this sentence and then put the number at the end that you were referring to. Okay, so I have my comparison word, greater than, to help the reader really understand what they're reading about what I had to say, so they're not having to remember what the graph said, that they can read it here. Our last one that I talked about was variability. So I said the only variability you really know a lot about right now is range. So the range of the student distribution is 48 shoes, which is greater than the range of the teacher's distribution, 29. Okay, so I used my comparison word. Greater than, I had some student and teachers. I had some context in there. I gave evidence using the numbers. So this really is what I'm looking for when we're making a comparison. Write out SOCV, address each thing, make sure you're using comparison words, and you should be good. All right, let's summarize this down. All right, so I wrote this in red because I really want to be sure you remember it. Use comparative words when comparing distributions, okay? Put stars around it, make it in red, put it in glitter if you've got it. Just you got to be sure that you use your comparison words. Okay, so when we're talking about when we're describing our distributions, you want to use your soft language, like those LY words, okay? If we're talking about shape, we really only have 3 shapes that we're focusing on: skewed left, skewed right, or symmetrical. If we're outliers, include mentioning any gaps in the data and potential outliers. Then we have our center, use the mean if your data is symmetrical, median if it's skewed. And then our variability, how spread out is your data? Right now we did range, which is your max minus your min, but there are other ways that we'll be learning along the way also. All right, so hopefully that was helpful. If you haven't already, make sure you do the check your understanding. Let me know if you have any questions. I'll see you in class.
Yeah.